Today, I'm going to lie to you. And I'm going to lie to you in a way where it's going to be challenging for you to find out which of them are lies and which of them are not lies. So the astute ones amongst you will begin to understand what exactly when I'm saying I'm going to lie. Let's begin. When I was in 7th standard, they told me that light is a ray. It travels in beautiful straight lines, bounces off surfaces, following a very beautiful geometric law. Angle of incidence equals angle of reflection. And it bounces off, comes here, comes there, and beautifully goes this way. Life was very beautiful. Until I went to 11th standard, and all of a sudden, which you will go there very soon, suddenly they told me light is a wave. It behaves as if you throw a rock into water, there are ripples, and light is very similar to that. And I said, okay, fine, I can live with that. And then I went to 12th standard. They told me light is a stream of particles. It's like you have a machine gun, you have a torchlight, you open it, it's like you have a machine gun and start shooting out little bullets of light. And those little bullets, they called photons. And I said, okay, now I'm beginning to get confused. To top it all, by the end of 12th, they told me, now we'll tell you what light is. Light is both wave and particle. Or they say neither wave nor particle. Which of it is it? They also said that, it depends upon what experiment you perform. Sometimes light will behave like a wave, sometimes like a particle. And by now, if you're not confused, then you're not really listening. Because I was very confused. And then I began to ask the question, what really is light? In order to answer this, we have to go into the deepest parts of what science really is. And is science trying to say something about reality? Are we trying to find out what light is? Nobody can say. The best analogy to take would be to ask you this question. Have you seen a political map of India? You'll see that it has states, it has capitals. Very simple, clean. Have you seen the physical map of India? It'll have mountains and little rivers and all that. Then you have a road map, right? Which tells you, you take these roads, you can go somewhere. Now, which of them is India? Is that a bad question? Or is it a difficult question to answer? Because which of them is India? Are all of them India? Is none of them India? Because if you try to build a map that has everything that has India in it, that India has, you'll have to build another India. So it's not the point at all. You want to build something that is not really the question where it's right or wrong, but we're trying to build something that is useful. Because what's the point of a roadmap? To tell you where to go. So if you have to find out where to go, which map will you go to? The road map. If you want to know how the cities are divided and how the capitals are, you'll go to the political map. If you want to find out where the rivers are, where the mountains are, you want to predict weather, you'll go to the physical map. Why am I saying this? It's because the real question is, we don't know what really is. Nobody knows. Nobody knows what light really is. But we are building a map of what light could be. And if we imagine light to be that way, then we can make predictions in a better manner. That's what science tries to do. If I imagine light to be a ray, will it be useful? If I imagine light to be a wave, will it be useful? So the question, is light a ray or is light a wave, is really a pretty bad one because we don't know. So when is light as a ray useful? If you want to build and find images, you want to build a telescope, you want to build a microscope, imagining light to be a ray works really well. If you want to find out, and answer questions about why light sometimes interferes, there's something called interference that happens in light, something called diffraction, which you will learn later. And if you want to understand why those happen, it's better to imagine light as a wave. If you want to understand certain other phenomena like photoelectric effect, you think of light as a particle, a stream of particles called photons. And it's pretty surprising that we don't really know what light is, but depending on what situation it is, we imagine light to be one particular thing. Now, this is what science tries to do. It tries to build a map of reality. And maps are never really a description completely of reality. But as long as they're close enough, they can start predicting what happens. Because Rutherford's model of the atom was wrong. It was wrong. We all know that. But using Rutherford's model, we built plastic chairs. And the moment we realize Rutherford's model is wrong, do the plastic chairs vanish? They don't. They're still here. Which means even a wrong model can predict good things and you can make things out of it. In other words, the real question to ask is the model useful? So we'll finish this off by making one statement. The map is not the territory. You have a map of something? Let's find out how useful it is. So in this particular episode, we will treat light in the most simplest form it can be treated, as a ray. So we'll imagine light to be a ray that goes from one place to another, gets bounced off, the most beautiful way of thinking about it, the most simplest way. The simplest way rather. So let's make some predictions looking at light as a ray and see how we can play with it. And let's really see what begins to happen. So how do we see? We see something around us. That's how we live. We watch everything around us. How exactly do we see? Now, long, long ago, there was an old man, who predicted theoretically that light leaves from our eyes, goes in all possible directions. And when it hits something, light comes back to our eyes. And then when the light comes back to us, we see. Isn't there a problem here? Because somebody switches off the lights, we're not able to see. If light goes out from our eyes, then we must be able to see whether there is outside light or not. So he wasn't the brightest candle on the cake. But now we know that there must be some way in which we are seeing, because we always need something called the source. Otherwise, we can't just see things. So we need a source. We have a receptor called our eye. The light starts from the source, hits something, and comes back into our eye, and that's how we see. So all seeing happens using reflection, and we already know this. And typically, it's going to be irregular reflection, because some objects reflect regularly. You know this. And some objects reflect irregularly. All the objects we see around us, except heavily polished surfaces, are going to reflect irregularly.